Hi guys, this recording is for lesson 3.3c. So at this point, hopefully you have already gone through and finished everything from all of your packet pages prior to lesson 3.3c. In this lesson, we are going to try and figure out how to write the name of an ionic compound when it contains a transition metal. And this is, I will say, maybe one of the harder parts of this unit. Students do sometimes struggle with this, so just keep at it, keep practicing, and remember those office hours are available if you need them. So first, I want you to think through how are transition metals different from S&P block elements, and I want you to think about their orbitals. So what I'd like you to do is pause the video here, think through this for a second, and think, wait, what even are transition metals? We keep skipping them. What's different about them? Pause the video, go ahead and put your answer, and then I'll go through it in just a moment. Okay, hopefully you've paused. I'm just going to trust that you have already. And we're going to go to our periodic table to think through this. So our transition metals are this pink section on the periodic table. If I was to write the electron configuration for, say, scandium, it would end in 4s2 3d1. So the thing that's different when I'm thinking about orbitals, the thing that's different about transition metals is that they contain electrons in their d orbitals. And those d orbitals make them behave a little bit funky. Because they have these d orbitals, they're able to take on different kinds of charges. They can have different oxidation states. And so that means scandium could have maybe a 1 plus charge or a 2 plus charge. They're not as nice and clean cut as, say, magnesium, which I know no matter what will always have a 2 plus charge. Scandium could have a couple of different oxidation states. So that means it could take on a couple of different charges. As always, remember that metals are always going to be my cations, my positive charges. So when I'm talking about my transition metals, they will all have a positive charge. That positive charge may just be different. So remember, my metals always have positive charges. My non-metals are always going to have my negative charges when they're in an ionic compound. All right, so to answer this warm-up question, I'm going to say they contain electrons in their d orbitals. And then here I kind of got ahead of myself and started talking through a little bit of this. So transition metals have different oxidation states, meaning that they can take on different charges. When we're writing the name of an ionic compound that contains a transition metal, therefore, you have to tell me which version of this element is included in this compound. So if I think back to what we've done already, so if I'm thinking about like NaCl, for example, there is only one way to make this compound because sodium will always have a 1 plus charge. Chlorine will always have, chloride I should say, will always have a 1 minus charge. So when I crisscross, the only way to balance out these charges gives me a 1 and a 1. If, however, I'm thinking, so what that means is that when I'm naming it, all I have to say is this is sodium and this is chloride. There's no version of sodium that could be contained in this. So the name of this is just sodium, whoops, my pen just did something weird, sodium chloride. If, however, I'm thinking about iron chloride, well, iron is one of those transition metals. Iron with a +2 charge exists. Iron with a +4 charge exists. I think iron with a 3 plus charge also exists. There are all these different versions of iron. So if I tell you iron chloride, well, that could mean anything because I don't actually know what this charge is. So I can't work backwards to figure out what that formula was. So this could be Fe2Cl, let's just say that. I think that would be a 1 minus on here. No, it could be FeCl2, there we go. And that would be equivalent to 1 Fe2 plus and 2 Cl1 minuses. So it could be this. Or if I'm saying iron chloride, that could mean FeCl4 where this is Fe4 plus, and then 4 Cl minuses. And those are entirely different compounds with entirely different behaviors. So I can't just say iron chloride. If I'm talking about this one, I would have to say iron 2 chloride, because that tells me what kind of iron I have. I have iron with a 2 plus charge. If I'm talking about this one, I would have to say iron 4 chloride, because that tells me that this iron has a 4 plus charge. Oops, I don't have an E there. So when I'm writing the name of an ionic compound that contains a transition metal, I have to include Roman numerals to tell you what charge the transition metal has. So the Roman numerals I'm including are the charge of the transition metal. And we know they're always positive, so we don't put it as +2, we put it as a Roman numeral. So we're going to go both ways here. We're going to go from the name of the compound to the formula of the compound. So if I see iron 4 chloride, how can I turn that into FeCl4? And then we're going to go from the formula to the name. So we're going to say, okay, if I know FeCl4, how can I get to iron 4 chloride? So to get from the name to the formula, to get from iron 4 chloride to FeCl4, this is the easier direction. So this is the easier, this is the harder direction. So to get from the name to the formula, well, that's not too bad because my charge is right here, and then I can just crisscross. So I'm just going to use the charge in the Roman numeral as the charge for my metal, and then I'm going to crisscross. So if I had iron 4 chloride, I would say, okay, this is Fe with a 4, so that's 4 plus. Chloride tells me this is Cl. I use the periodic table to figure out this is 1 minus, and then I crisscross, which gets me back to FeCl4. So I just use this. It just basically makes it so I don't have to even check the periodic table for my metal because my charge is right there. So this direction, not too bad. I just use the Roman numeral as the charge of my transition metal. I find the charge on my anion using the periodic table, and then I crisscross. I'm just going to erase this so there's not too much clutter up there. Going the other direction, however, is a little bit harder. So what we have to do is work backwards to figure out what was the charge on that metal cation. So I like to use this table, but some students find this table a little bit confusing. Ultimately, what I'm doing is I'm saying, okay, I'm going to use the charge on my anion, and I have to figure out what charge of a cation balances that to give me a neutral compound. So for example, with FeCl3, what I can do, so I'm going to do it without the table first, and then if that's easier for you, go for it. If the table is easier for you, use that. So I'm going to do it without the table first. So if I just have FeCl3, this is the question I'm given, and I'm trying to come up with the name of this. I know it's iron something chloride, and I know that this is going to be the charge of the cation, of the metal. So that's the piece I'm missing to get to the name here. So I have to work backwards to figure out, to balance it out. Now, I like to use this table. The other thing you can do is just think about the anion. Okay, Cl, I know that the charge on that is 1 minus. I know I've got Fe over here, and I know there's only one of them. So I know some charge here has to balance out with all of my Cls. I'm just going to draw them all out. Oh, let's be a little more consistent than that. There we go. Oh my gosh, my brain. Okay, so I know in total I've got 3 minuses here. So I'm trying to ask myself what charge is in this Fe to balance that out. Well, there's only one of them, so that must be a +3 charge. Which means when I write the name, I'm going to put 1, 2, 3 as my Roman numeral. All of the symbols for the Roman numerals are here. So if you forget any of them, make sure you're checking them here. You really won't see any Roman numerals higher than 7. I don't think I've ever seen a Roman numeral even higher than 5 as an oxidation state, although I shouldn't say that's probably possible. Transition metals do weird things. So what's up with this table? So the other way you can do this is, let's say, I'm going to just scribble over these so we can kind of fill this in together, and you can see how I would complete this table if I were using it as a tool. And I would just use this as a tool kind of on your own paper. So if I was using this as a tool as a student, what I would do is I would just start by filling in what I know. So, okay, I have FeCl3. I know I've got to figure out my cations, and then I have to figure out how many of them gives me my total positive. My anions times how many there are gives me my total negative charge. So I'm going to fill in my how many's first by reading the formula. So I have 1 iron and I have 3 chlorides. And I need this to equal this. So then I'm saying, okay, what's the charge on my anion? That's my Cl. It's a Cl1 minus, which I figured out with the periodic table. So this is going to be a -1. That means over here on the right, my total negative charge is -3. Okay, that tells me I need this number on the left side, on my blue side. My total positive has to be +3 because these have to be the same size and opposite charges. So if this is -3, this is +3. And then finally, I'm able to work back to my unknown that I'm solving here, which has to then be +3 because the only thing that times 1 gives me +3 is a +3. So you don't have to use this table if this setup makes sense for you, but all I'm doing is I'm asking myself, what is the positive charge that will balance out the total negative charges from my anions? The reason I like the table is because this gets more complicated when we have more than one of that cation. So for our next example, to try and figure out the name of Fe2O3, I've got to figure out the positive charge on my Fe again, because I know this is a transition metal. So in order to name this compound, I'm going to go through and use this table, and then maybe you'll see how it's a little bit helpful when we have multiple cations in our compound. So I'm just scribbling these out so it's easier for you to follow along kind of how I'm thinking through this. And the order I think about it through. Okay, so I have Fe2O3. So what I'm going to do is figure, okay, this is my unknown. This is what I'm trying to get to. And that's what's going to go into my name. I know this is iron something, whatever that charge is, oxide. And I have to figure out what charge that iron has so that in my name I can specify which type of iron is in this compound. And there really should be more of a space between my parentheses and my oxide. That is 2 words. Space, oxide. Okay, so I'm going to fill in my how many's first. I have 2 iron, 3 oxygen. I use the periodic table to figure out what's the charge on the oxygen. Well, it's -2. So that means my total negatives have to be -6. To balance that out, that means I must have +6 over here on the side of my irons. My cations must also be +6, which then I can work backwards to figure out is a +3. So this is going to be 1, 2, 3. It's kind of like the anti-crisscross. I'm kind of uncrisscrossing to get back to what was the charge on that cation. To check your work, you can always crisscross. You can say, okay, Fe, I have a 3 plus, O, I have 2 minus. Does that get me where I need to be? Yes, it does. Fe2O3. So if you're trying to check your work, crisscross using the charge you've figured out to make sure that gives you the same formula that you have. The other way we could have thought through this is we could have said, okay, I have all my O's have a 2 minus. There's 3 of them. And then I have Fe with some question mark charge up here. And I'm just trying to think through what are the charges on these FEs to balance out. So if it's more intuitive to do it this way for you, absolutely do it that way. Whatever you need to make sure you can figure out what is the charge on that cation, because that's what has to go into the Roman numeral when I name this compound. So if this works better for you, just do it that way. If the table works better for you because it's like following steps, just do it that way. All right, and I'll do a couple more examples on here for you. I'll do one each direction, and then your assignment for this last piece of the packet for this section is going to be to finish out these examples. So I'm going to keep practicing. I'll keep going through from compound to name, because then you'll see when I do the example the other direction, it's a lot easier. And so I'm going to do one more of the hard one, and then I'll do one of the easy one, and then the rest will be for you to complete. So I'm going to do this one because I think it'll be challenging. And then I'll do one that has, I'll do that one because that one has both a transition metal and a polyatomic ion. And then I'll just do this one so you can see how that works. All right, so first I'm going to do Cu3PO4 So I know this is, let me go to the periodic table, figure out what Cu is. And when I do that, that tells me that Cu is copper. And I know copper is a transition metal because when I go to the periodic table and I find Cu, oops, that's not the periodic table. I find that it's in this pink section, so it's a transition metal, which means it can have different oxidation states, it can have different charges, and so filling in its name, I need to say specifically what version of copper is this, and put that into parentheses. And then PO4 in parentheses, that tells me, wait a second, this isn't just a single element, so I'm not just going to write the single element with the "ide" ending, I'm going to have to go back to my table with polyatomic ions, and figure out what the name of PO4 is. So PO4 is right here, that is phosphate. So I don't have to change any endings to "ide. I'm just going to fill in for my anion. I've got phosphate. So then the hard part is filling in these Roman numerals. How do I balance out copper and phosphate? And while I was up there, I should have also looked at phosphate's charge. Phosphate has a 3- charge. Remember, this is the same as if this whole thing was in parentheses, and that 3- is on the outside because that 3- is the charge for the whole thing. So what I'm going to do is I'm going to say, okay, I've got my Cus over here. I've got my PO4s, and they all have a 3-. I'm going to do this one just kind of drawing it out without the table. So PO4, I've got 2 of them. So that means I've got 2 of these because it's 2 of this whole thing. Copper, I've got some charge on it. And I'm asking myself, okay, what does the charge on these 3 ions have to be to balance out with these 2 ions? This is a -6. This, therefore, has to be a +6. There are 3 of them. The only way to get a +6 when I have 3 of something is for it to be a +2, +2, +2, because I'm asking myself what times 3 will get me to +6. If you want it on your own paper, draw out the table and do it that way. That is fine too. But that tells me that each one of these has to be +3, +3, and +3, which means that in parentheses I've got 1, 2, and 3. Let's see, what do I want to erase? I guess I'll erase the question marks since we figured them out. Okay, so that's the last one I'll do of these. And then let's just see how much easier it is going the other direction. So going the other direction, all I need to do is say, okay, I'm just doing a crisscross. So lead is going to have a +2, and I know that because that's what's in parentheses. Lead, when I go on the periodic table, is Pb. All right, and then I changed the example we're going to do from lead to iron because lead is not a transition metal. Lead only has 1 charge. So that should not have the Roman numerals. Okay, so instead of lead 2 chloride, we're actually going to do iron 2 chloride. So I am going to figure out what is the formula for iron 2 chloride. And it's so much easier to go this direction because I've already got my charge right here. It's going to be a +2. So I'm just going to crisscross. I have Fe, and it has a +2 charge. I have Cl, it has a 1 minus charge. And all I need to do is take this 2 and make it the subscript here, and this 1 and make it the subscript here, because that'll balance my charges out. I have Fe1, and I don't need to write that one, Cl2. All I need to do, and thinking through, making sure that those charges make sense. This is Fe with a 2 plus. This is 2 Cl1 minuses, which adds up to a -2. So those do in fact balance out. So all I have to do here is FeCl2, and I'm happy. All right, so as your exercise, you have 1, 2, 3, 4, 5, 6, 7 to complete for you to practice.